Okay, guys, so we're looking now at lesson 2. Now, you girls will have to be quiet, otherwise your little voices will be on the video, right? Okay, so if you're looking at 12-1, we're starting with prisms. Now, a prism, by definition, has two bases that are the same shape and size, and they are parallel to one another. Okay, so if you look at the first picture there on page 475, you see that the bases are what shape? Those orange shapes are hexagons. They are congruent hexagons, and they are in parallel planes to one another. Now, look at the things you need to know about those. The altitude is the perpendicular distance between those bases, just like it is for a lot of things. The lateral edges, those you can see the arrows pointing to the lateral edges. The lateral face is the side when you hold it vertically. Okay? So those are some things that you need to know. All right? Now, take a look at the prisms on the bottom of the page. We have right prisms, 3 right prisms, which all are perpendicular. So the base is perpendicular to the lateral faces on all of those. Okay, that wasn't true with the hexagonal prism, was it? But the ones on the bottom are all right prisms. So we have a right triangular prism, a right rectangular prism, and the lateral edges are altitudes because they are perpendicular to the bases. Right? And that's what we said about altitude, isn't it? And then the third one is an oblique pentagonal prism. So that must mean that the one above with the orange hexagons is an oblique hexagonal prism. It is. How cool is that? All right. So prisms have congruent polygons, top and bottom, but they may not be top and bottom, okay? But they are parallel to one another. All right. Okay, now take a look on page 476. The first thing that you need to know is surface area. I tend to think of surface area as how much wrapping paper you need to cover a box. Because when I was a kid, we didn't have gift bags. I know that seems bizarre, primitive, whatever, because we've had them for decades now. But when I was a kid, you had to wrap the Christmas present with wrapping paper. Okay?
Life is hard.
We had to, I know, life was really difficult for us. The paper cuts, I'm telling you, it's just shocking. So, I think of surface area as how much wrapping paper it takes to go around something with no overlap. Okay, because with wrapping paper, of course, you have to overlap, I mean, there have been times when I'm like, have I got enough? Right? But generally speaking, there is overlap. Okay? Now, the lateral area of a prism is the sum of the areas of the lateral faces of the prism. Then the total area, TA, is the sum of the areas of all its faces, because the bases are faces. They're just not lateral faces. So look at the little formula they give you there. TA, that's total area, equals lateral area plus the 2 bases. And all of those capitals mean that we're referring to the area of those surfaces. That's what those capitals are. So when it says 2B, it means 2 times the area of the base. All right? Look at theorem 12-1. The lateral area of a right prism equals the perimeter of a base times the height of a prism. Can't talk, okay? The lateral area of a right prism equals the perimeter of a base times the height of the prism. That saves you some time. Let's think that through, okay? Look at the example down below that. The formula for lateral area applies to any right prism. Oh, no, 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 no. That's not what I want. That's silly business. That's not what I want. I'm going to start drawing prisms on the board so that you can see what I mean. All right, we're going to do a rectangular prism. And this will also help you learn how to do prisms. All right. Oh boy, that one's wonky. It's a box, isn't it? It's a box, it's a box, it's a box, box.
We should make a song up for everything. Yeah, we should.
You think?
Yeah.
Song and dance, song and dance. All right, it's a very bad prism, I must say, and I forgot to do the dotted line here. So, very poor prism.
Beautiful.
Okay, you think so? You are so kind. All right, so when we are looking at lateral area, let's say that this rectangle is 8 by 4. So it's a rectangular prism with area 8 by 4, and the height is 13. Okay? So to get the lateral area, we do the perimeter times the height. The perimeter, what's the perimeter of the base? 24. And then the height is the 13. Okay, so multiply that out and that gives you your lateral area. That saves some effort because you do not then have to go, okay, this rectangle is 4 by 13 and this one is 4 by 13 and this one is 8 by 13. You don't have to do all that. You get the perimeter, multiply it by the height, and that is how you find the lateral area.
Where did you get 24?
Somebody gave me 24. Did somebody lie?
Daniel.
It was
No, it's
Landon.
correct. It's the perimeter
Yeah.
of the base. 8, 4, 4.
Oh. Whoa.
And it's not even Monday.
It had me doubting myself for a second.
Have me doubting myself too.
Yeah.
But that's okay. It keeps us on our toes. All right, so yes, the perimeter of this little rectangle. Poor Caroline. Oh. Now, the same happens with triangles.